so bad. I don't know if it's already recorded. Yeah.
Okay, now, yeah. Okay, hello guys, this is Carlos. Well, as you can see my screen now, right? The slides.
Yes.
Okay. Okay, we're going to talk about today about Git Bisect. It's a tool that you already have in your system. You don't need to install anything. I'm going to show a small example how it works. And let's get started. I'm going to hide my camera. Just I wanted to show you my face. But for performance stuff, I'm just going to turn it off, okay? Okay, a little bit about myself. I'm a software engineer for more than 8 years of experience. I've worked with a lot of technologies, several kind of technologies. I passed through PHP, Java, and now I'm working with JavaScript completely. I've been working in Cognizant since 2021. If you want to know more about me, you can find my profile in several social media like GitHub, LinkedIn, or Medium as Calverts, which is my username. And let's start with the Git Bisect stuff. Let's say we have a team. This is a very common case. I'm sure you have passed through this kind of scenario. So let me show you how it is. Let's say we have a team, and now we have a repository. This repository has a develop branch. Now we have Bill Gates doing his first initial commit. And also we have another player, which is Linux. It's working in another branch. It's a feature branch. He's adding more code. At the same time, we have Elon Musk working in another feature branch, doing his work. And at some point, we want to add the code into the develop branch, which is very common. But for some reason, Elon Musk, in this case, made a mistake, break something in the repository, in the application, but he didn't notice and just merged his changes in the develop branch. At the same time, Linux continues working in his branch, adding more commits. And we have another player here, Zuckerberg add more work to the develop branch. And Tim Cook also add more work to the develop branch. So now Linux wants to merge his commits into the develop branch. So what he does is running a rebase, git rebase, bring all the commits from the develop branch and put him under his commits. His work now is on top of the rest of the commits. But he realizes there's something that is not working properly. And but the problem here is that he doesn't know where the problem is, which commit breaks all the application. I know it could be controversial, the thing about rebasing stuff. This also could work with a merge approach. If you don't work with rebasing, that is not a problem. This is just for the example. And now you have two options when you have these kind of problems. You can waste your time, basically doing the manual debugging across the commits you have in your repository, seeing code you don't understand fully, or you can use a tool like Git Bisect and try to find the commit or the place where the problem was introduced. So the idea in this presentation is to use obviously Git Bisect. How I show you how this could help in your daily basis to find problems quickly and not doing manual debugging, because it's frustrating when you actually have to look for code that you don't understand. This is especially useful in large code bases and large teams. Now we have a few commits here, but imagine that we have hundreds of commits. For example, you are 50 people working in same code base. In daily, you have adding a lot of commits. So this could be very challenging, and you need something that can help you to find problems quickly. So let's continue. How the Git Bisect works, how it works in the command line. Okay, as I told you before, we already know that Linux knows that his commit is okay. His commit, he's sure that his work is okay, but at some point in this history, in this point is failing, that the application is failing in another place. He knows that there's something in the middle that is broken, but also he knows that the initial commit, the one that he used to start his branch, it's okay, it was good at that moment. So what we do here is just use git bisect. We run a command that is git bisect start. Git bisect start, we put the repository in bisect mode, and we have to tell Git which is the bad commit. We don't know which is the bad one, but we know that at some point the repository is bad. So in this case, it's the head, the latest commit. At that point, the repository is broken. And we had to tell Git also which was the latest good commit we know. And we had to pass, here works, anything works, the reference, it works a branch, you could use a tag or a commit ID, which is the example I'm going to show you. And after this, we have to tell git bisect running a script. In this case, it's npm test, but it could be any script. It could be any thing that you want to validate. Keep in mind that this is not about unit testing. This could be anything. For example, imagine that I want to find the moment where a line was added to a file, for example, a line of code, or where the performance was got worst. So this is very flexible. I'm using npm test in this example, but it could be any script. How it actually works? Well, it just do binary search. You already know that binary search is just take a little number, order numbers, and just pick up something in the middle, discard a half of the commits, and moves continues doing the same until he finds something that is broken. In this case, git bisect, what it does is just pick something, a commit in the middle of the bad and good one, validate running the script in that commit. If that commit is okay, he just discards the half and picks up the other one and repeat the process again until he finds something. The output will be something like this. When he finds the commit, he's just say this is the first bad commit and shows you the outflow in the commit message and stuff like that. Okay. So imagine that this tool, this is very powerful tool. This is a very basic usage in this example, but there are many usages of this tool. You can see git bisect. The documentation is very extensive. You can change the alias. You can use a different word instead of bad. You can use another one. You can change a lot of things. So it's very flexible. Now imagine that we want to have a very full automated QA process. For example, you have Jenkins with Docker or whatever, it doesn't matter, any pipeline system, and you want to run some integration test at midnight because you want to make sure everything's working. And these unit tests maybe are not that fast as the unit test. This integration test sometimes takes more time because it has to start a browser, taking some screenshots, stuff like that. So it takes more time, and we don't want to run this test in every single commit we do. So we can create a pipeline where we check out the project, we run the integration test. If something fails, we can run a Git Bisect from the head, which is the place where it's broken, to the last head that was good, the last known good. And after that, imagine that we can automate the Jira creation ticket, notify by Slack or Teams or wherever, and notify the QA team. Just they know that there's something that is broken and there's a new issue that was opened into Jira, for example. This would be great to avoid just wait until the QA team finds a problem in later stages of the deployment, for example. That's why this tool is very interesting. There are some conditions you have to make before to be able to use this tool in this way, but this could be a very great goal to have in a project. Okay, so now I'm going to show you a demo. Let me. Guys, if you have any question, please write it down in the chat. We can see it after I finish the demo. Okay. Now I have this repository. This is a very simple project. This is only one file. This is very simple. It's just a server that push some logs and prints the memory usage. That's it. For some reason, this project is failing, and I want to know why. So I have some scripts to verify the memory usage. So I'm going to run some tests here. And as we can see, the memory consumption is increasing with no limit. And the process at some point will crash because there's no memory left. So this is happening in this project, and we don't know where the problem is because the latest commit was just adding a log where we print the memory usage, but the server is crashing because memory is stuff. So the problem should be behind of this commit. So let's go to the initial one. I'm going to the initial commit, and I want to verify if this commit is broken also. So it looks like this commit, it's okay. The loading tests are working and the server is not crashing. So the problem should be in the middle of the, let me go back. In the middle of this history. Now this is very small history, but imagine you can have a very large history, a lot of commits, hundreds of commits. So it could be really hard to understand what is the problem here. So as we don't know what is the problem, I'm going to start our Git Bisect here to find which is the problem. Now I'm going to tell Git which is the bad commit. In this case, is the head, which is what I'm not right now, the latest commit in this branch, and this is the bad. And the good one would be the initial one. So now you got it. Now you have the repository in a Git Bisect mode, and now it's just missing telling Git running a script. In this case, it's a load test script. Sorry. So I'm saying Git Bisect run, and the script we want to Bisect running. In this case, is npm run load test. So what it's going to do here is try here. So he starts doing the load test in every commit he picks, depending on his algorithm, the binary search he does. And he's trying to find where is the problem here. So as you can see now, this is the output. It says the first bad commit is this one, the ID commit. And I already know this was the bad one. That's why I just put this message here to show you that this was the commit that breaks all the repository. It's the commit that has this message. So after we find this problem, we can just say git bisect. We back to the develop branch, the latest commit. And now I want to see what is that commit. So that commit is this one. That's the one that introduced the problem. And what it does is just stringifying the request logs. And that's why it's taking too much memory. And every time we do a request, the array is too huge, is huge. So that's why it crashes because of memory. So what I'm going to do is just commenting this line and doing rest and without anything, just for example. Now I'm going to run the start graph to see how the memory behaves and running the loads. And now, as you can see, the memory consumption, it's fine. It's stable, it's okay. And that's how Git Bisect can help to find problems in your code, in your project. Let me, okay. That's how the Git Bisect can help you to find stuff. And this has some limitations, to be fair. Not sure if you're seeing my screen, but well, it has some limitations. One of the limitations are if you don't have a very well organized history, for example, that will be a problem. For example, here I have this history, which is very linear history, and that makes the binary search easier for Git. But if you have here a Christmas tree, for example, something that is very nested, very disorganized, you will have problems, not because Git is not able to run and going across the repository, but because you can have false positives. You can have a false positive saying this is the culprit, but maybe the culprit is in another place or is actually behind that one. So having a linear history, a well-organized history, it's important to take advantage of Git Bisect. If you don't have a linear history, it will be, you can use it, but it won't be accurate when it comes to return the commit that is actually broken. And if the commit is too far away, for example, if the commit is too far away from the bad one, from the head, you will be analyzing great stuff, amount of code, amount of commits. And what if you have, for example, here, as you can see, I have the scripts that I've used to test here, but what if this has changed during the time? What if I have changed the test, for example? Every time Git changes the commit to evaluate the test, the script, if the test has changed because the commit was changed, that won't be accurate also. So that's why Git Bisect, I think it's nice using as an external tool. I've used it here as like inside of the code, but just for the example. But if you have a large code base and you want to find a problem that is something very far away from the latest commit, and you know that you have changed the scripts during the time, I think in this case you have to use it as externally tool, and you have to have a script that is external to the repository. to make sure you're evaluating the same in every comment, for example. That's one of the limitations I've seen using this. And that's pretty much all the thinking, guys. That's all for me. And not sure if you have any questions.
If you have questions, don't be shy. Or just
I
sorry.
have a quick one. Which is so basically when you pass a script to Git Bisect to check, the only specifics of the script that you pass is that it has to return with an error code in case of error, right? That's it.
Yes, you have several possibilities. Git Bisect supports several exit codes you can return to tell Git Bisect, for example, do not evaluate this commit. So you return a special exit code to skip that one, for example. Yeah, there are several options you have to conduct to tell Git Bisect where it has to go. But I didn't want to dive in those options. But yes, if you read the documentation, you will see there are several exit codes you can use to tell Git Bisect when skip something or when not.
Okay. Thank you.
Hi, I have a question. Even though you said it would be complicated if you have a kind of a large or complicated history in your branch, it will be narrowing your search, right? I mean, maybe it won't indicate you the right point, but it will narrow pretty much the search, right?
Yes,
I mean, comparated if you do it manually.
Yes, compare manually. What Bisect does is just discarding commits that it considers are okay. That's that's the difference. So yes, you can try just giving a very limited range of commits. If you have a large base, well, it doesn't matter. It will run and it will discard the middle, and the middle it will be fast. But the problem is not the speed in this case, but the changes across the repository. So you can have a false positive. So a false positive is very possible if you are evaluating a very large range of commits and the code has changed a lot. That could be a problem, you know. So that's why if you pass a more limited range of commits, it will be more accurate. The possibility to have a false positive reduces, basically.
Okay, thanks.
Anyone else? Anyway, if you have any questions, I think you can reach him directly, right?
Yeah, sure, of course.
So if you don't have any more questions or suggestions or whatever, we can conclude here. I would like to thank you, Carlos, because I think it was really interesting. And invite to all of us, if you are interested on giving any talk, just contact me and we can organize it. Thank you for everyone to be here again. Have a nice day.
Everyone.
Thank you.
Okay, thank you very much for the talk.
Thank you. Bye.
Bye bye.
Thank you. Bye.
Thank you.